Hello, welcome. Let's try to solve another Leetcode problem. It is 7, Scramble String. So let me first explain the problem. So from the beginning, we have two strings, S1 and S2. So this is S1, it is great, and S2 is RG eat. So we're gonna do some operations of S1, and after the operation, we're gonna check if the final string equals to S2 or not. Let's just check the operation for this example. So from the beginning, we can split it from this position. Let me draw it. So we can split it from this position gr with EAT, and gr will keep the same, and EAT will also keep the same. And next, we're gonna split it from this gr. It's gonna be g and r, and EAT, and we're gonna split it from here, E with AT. Now, what's the next step? So for the next step, gr we're gonna keep the same, and for this EAT, so for this gr we're gonna change it to r and g, and you can see that r and g equals to here r and g, and this EAT we're gonna keep the same, and for the next, this r and g it's the same, and for this EAT we're gonna turn this EAT to separate EA and T. But this EAT will be together for the next change. So for the next, this RG gonna be the same, and this AT, this E and AT will keep the same. So our final result is RGEAT, and this is also RGEAT. So it means we got the same string, the same order. So this means we can return true. If we tried all the possible cases, we cannot return F2, so we're gonna return a false. So by analyzing the problem, it seems a really hard problem. But we can solve it in a simple way. So for example, we have a string. So this is a string. Let me just define it from 0, and the length of the string is L. So the index is L minus 1. So in order to solve the big problem, like this problem, why not we solve the sub-problem? I mean, we can solve it recursively, like divide and conquer. If we cannot solve the big problem, why not solve the sub-problem first? If we can solve all the small problems, all the sub-problems, then it means our big problem has already been solved. So this is S1. It is from 0 to index L minus 1. So L is the length of the string. And here also 0 to L minus 1. So this is S2. So why not we just compare by the smaller problem? So for example, we're going to enumerate. We're going to use index I to enumerate all the different cases. So if this area equals to above and below area, if they are equal, so for example, this is like RG here is also RG, it means they are equal. And what if the right areas, these areas, equal to the below areas? So if these areas, left areas equal to the left areas of S2, and right areas equal to the right areas of S1, so we are sure we can return true because everything gonna be the same. And we're gonna enumerate from the different places and try all the different cases. As you can see, the problem will be smaller and smaller. If we find some problem, maybe there's only one string. This is G, and also from here it is also G. And if the subproblem here is R, here is also R. Everything gonna be the same. So we can return true. But this is not the only case. So this means there are other cases, but how can we check the other cases? So for example, let me try another case. So another case is that we will not check at the left area S1 with S2 here. We're gonna check these areas. What if we let me try to make the drawing better. So let me delete these areas. So what if we solve the problem from here? Yeah, we're gonna solve it from here. So if this is I, and what is this index? We want to make this areas at the left of S1 equal to the right of S2. Yeah, and actually here is L minus I. Why? Yeah, we have to find some index, and then we are sure this area should equal to this area, and then we can use the recursive function to compare here with here, and this right of S1, this area is compared with left of S2. Yeah, we're going to compare like that. But the problem is, how can we find this L minus I? Why? I'm sure this is L minus I. Actually, this is also easy. For example, this is a 0 if this I is 1 and the length of L is 10. Yeah, so we are sure the length of this area is 1 because 0 to I, 0 to 1, we're gonna check it as only one element. So for here, this one should be L minus 1. So L is 10, 10 minus 1, it is 9. But the length is 10. So from the index 9, it is okay. So this means if we use L minus I, basically this area is equal to the S1 areas, the left of S1 and the right of S2. Yeah, and for calculation, we can also calculate it. Yeah, because here is 0, here is L minus 1. So L minus 1, this is I. We're gonna minus this I. Yeah, but this index minus this index, normally we need to plus 1, that is the whole length. So we need to minus I and plus 1. So it means this areas should be equal to this areas. So finally, this is gonna be L minus I. Yeah, if you are not sure about the formula, maybe you're gonna try some examples. If this is 1, and we're gonna use L minus I to check. Definitely, if it is not L minus I, maybe L minus I minus 1. Yeah, but it is L minus I. Now our problem solved because we solved the subproblem. Yeah, maybe you're not sure why are we solve the subproblem. Because as the problem it becomes smaller and smaller, smaller and smaller. If there's only one element, for example, this is R, this is R, definitely it's gonna be true. This will be the final condition. If all the subproblems solved like that, so we solved the problem. Yeah. Let me continue coding. Actually, this coding would be much easier than you expected. We're going to use the DFS with memorization. We're going to prepare two strings of S1 and S2 together. We have to compare them together. Maybe you think, why not I just use one string S1 to change it according to this example to turn it to S2. But that is not the case. That would be much more difficult. We're going to execute S1 and S2 at the same time. So our edge case is if S1 equals to S2, yeah, because if they are the same, we don't need to compare. Yeah, we're gonna return true. For example, this is a S1, great, and this S2 also equal to great, so we're gonna return true immediately. Otherwise, we can check the two different cases. So for I in range, I'm gonna prepare a variable L should be length of S1. Yeah, because S1 length of S1 equal to length of S2, so I'm gonna define it as L as the length of S1. It's the same. So for I, I'm gonna study, from 1 to L. Then I'm gonna check the DFS. So if DFS S1, I'm gonna study from to I, and I'm gonna compare S2 to I. Yeah, if they are equal, and similarly, let me copy it. So this is the first check. Yeah, if you check my drawings, it will be like that. And then we will check the second part, the right side. We just need to change this one to I and delete this one. So this is the first condition. Yeah, if the first part equal to the last part for both for S1 and S2, so we're gonna return true. Yeah. So the second case is that we have to check separately. Let me copy the code and change it from here. Yeah, I hope I can change it right. So still here gonna be the first part. It is a 2I index. Yeah, but for the second part it is not 2 not 2I. So yeah, for here it is 2I, but for the second part actually we need to delete this I, and here should be L minus I. Yeah. Let me, I think I need to go back to the drawing. Let me check if I can go back. Yeah, no. Basically the idea is also like that. So this is S1 and this is S2. So the second example is here. We're gonna check here, this is I, but from here, this is L minus I. Yeah, we need to compare this part with this part first. So for S2, it's gonna be L minus 1. Yeah, and similarly for here, we're gonna check the second part. So for here, we check the I, and then for this S1, yeah, we're gonna starting from I. Yeah, if we're gonna starting from I, for S2, it's gonna be from 0 to L minus I. Yeah, it is symmetric. I mean the formula L minus I to I. It is symmetric. We just need to, yeah, check all the cases. So if it is not true, we're gonna return a false. Finally, we just need to return this DFS with S1 and S2. Yeah. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. And for this problem, it's really difficult to analyze the time complexity, because basically this is the DFS. And here, why we can use cache? Yeah, because this is string and this is string S2, the length of them is only 30. It means it is a tuple of 60 elements. Yeah. Yeah. It means there will be 30 element with another 30 element. So it is 30 times 30. So this is a time complexity for inside of the DFS. Yeah. But outside of the DFS, we are still doing the recursive function. So inside it's gonna be smaller. Actually, the calculation is much more difficult. But yeah, because this is for the time complexity, it's gonna be really difficult to calculate. It's gonna be smaller and smaller. Actually, yeah, it seems the time complexity should be 10 to the power of 4 or 10 to the power of 5. Yeah, but we have to use a mathematical formula to calculate. Basically, it is like OT. Yeah, so the problem it becomes smaller and smaller. Yeah, if yeah, and then OT divided by 2. Yeah, I cannot analyze this time complexity, but yeah, that's for it. If we can think it as recursively, like divide and conquer to solve it, I think it is okay. Thank you for watching. See you next time.